Hello, everyone. Good day, good morning, good afternoon, good evening, depending where you're joining us from today. So today we'll be looking at a presentation of the brief on this week's module topic. Before we start, to those of us here now on your experience going through the material on Podia. Has everyone been able to go through the links? And if yes, what are your thoughts on consensus mechanisms before we go on to listen to Ovia? You can share in the comments or you can unmute yourself and speak. So feel free to share in the comments and unmute yourself. Okay, so Nicole says it's a program to achieve distributed agreement about the ledger state. Can we have more people actually give their responses to this, and then we can come back to these responses after the presentation and see how well we did with the response that we gave. And for our study group leads here, it would really be great if you could put a message in your different study groups to let others know that we have started this session. Hi, Kate. Hi, Zoltan. Hello, Melanie. If your study group lead, kindly put a message in your group chat to let others know that we have started. And also, we want to hear from you. What is your understanding about consensus mechanism? Can you hear me better now? Is my sound better now? Okay, so is it better? Thank you. So we'll take about 2 minutes to wait for responses, and then pray you can start playing the video at the end of the next 2 minutes. So please share consensus mechanisms. Let's know what your understanding of it is, and then we can come back to your different responses later on and see how well you understood the concept at the beginning of this session versus at the end. And so if I don't, okay. And so we have about a minute left. Let's hear from you about consensus mechanisms. It's going to be a very interesting presentation, but I also want to get your feedback, your responses before we start the session or before we start listening to Ovia. Okay, Pray, you can play the video now, and then we'll come back to this later on.
Okay, I see a couple of hands up. Okay, doesn't matter. So please I want this to be interactive. Please feel free to stop me at any time if you don't, if I'm going too fast or if you don't understand the word or anything like that, okay? So I'm here to talk about arriving at a consensus in a global distributed world. That's a mouthful, so let's break it down. Okay, cool. So what is consensus, right? Let me just what is consensus, right? Consensus is nothing but coming to an agreement among a group of people, among a group of systems, computers, between computers and humans. It can be anything. Just when there are multiple parties involved and you want an agreement or a decision between them, that's what consensus basically means. Okay. And what's the consensus mechanism? It is the set of steps that you have to follow to achieve consensus. Okay. Consensus is omnipresent, in my opinion. It is an integral part of our society because we humans are social creatures, right? We have to we have to live together, so we have to agree on certain things. So we need consensus. It's there in governance, it's there in democracy, it's there in politics, it's there everywhere you see. Like simple, even our notion of time. Okay, for me, I'm in India right now, and it's 8:30, and there is somebody we have come to a consensus on how we calculate time and what time each of us should follow. Okay, if you look at like air traffic control, for example, you're at the airport, there are so many things, there are so many flights, there are so many people that have to work together to make things efficient and smooth for the passengers, and there's a lot of consensus happening there, right? Even in academia. Okay, so if you're to get something done, right? If you're publishing a paper, writing an article, you submit it somewhere and they elect a group of experts to agree on whether to accept your paper or something. So there's consensus everywhere. And in the digital age, we're using our mobile phones. We want things to be fast. We want things to be secure, reliable. So in distributed systems, in distributed computing, consensus is a very important aspect. And even more so in blockchains and Web3, where in distributed computing, you have a group of trusted computers which are geographically distributed who have to come to a consensus. But in blockchain, you have geographical distribution as well as people who don't trust each other. So consensus becomes very important over there. So that's why consensus is a big deal. But it is not easy to achieve. Okay, so why is it not easy to achieve? Firstly, there are multiple parties involved and you want all of their needs met, right? You want majority in agreement and satisfied with the decision taken, which is the output of consensus, right? So it has to be fair to all the participating nodes. So, and that's one part of it. Among many people collaborating in consensus, there can be some adversarial nodes as well. You can have people who want to turn the decision in their favor by unfair means. So you have to deal with that. And the next point is the nodes that are participating in consensus are geographically distributed. They're not in the same room where they can just talk to each other and communication is fast. No, they're geographically distributed all over the world and they have to talk to each other. And when they talk to each other, they send messages. And messages take time to go across the internet. And in that time, anything can happen. The network may fail, the packages can be dropped, somebody can intercept it and change the content of the message. Anything can happen, and we should be ready for it. And networks can be dynamic. What does dynamic mean? So in blockchain network especially, in general, for example, when in our government, when we vote for the next in our next election, they conduct a poll, they conduct a citizens poll. They know how many votes to expect, and they know who are what. So that means the network is known a priori. The participating nodes are known a priori, and it doesn't change. But it is not like that in blockchain, for example. Anyone can join the network and anyone can leave the network at any time. So how do you make sure that people participating are there for the entire consensus duration and they don't leave in between, or new nodes don't get added in between? So networks are dynamic and extremely large. So permissionless and master slave. So as I said, in distributed computing, you have nodes that know each other trying to come to a decision together. But in blockchain, there are people who you don't trust. There are nodes that don't trust each other and they have to come to a decision together, which makes it even more difficult. And scalability. So coming to a consensus between 10 people is much, much easier than coming to a consensus between, let's say, 1,000,000 people, right? Million nodes. So the scalability massively affects consensus. So there are so many problems. Consensus is very important. We need it, but it is not an easy problem to solve. Okay, so let's look at what exactly we need. What exactly consensus should include, right? Consensus mechanism should enable participants to cooperate and work as a collective, allowing them to collaborate towards finding an optimal outcome that puts the interest of the entire group first, right? The process should be inclusive such that many people are involved and actively participating in an egalitarian process, and all of their inputs and decisions are equally important. Okay, and we also want that the decision and the consensus is useful, right? We can easily say, let's just all agree to make the decision as one, or just say yes, but that's not of real use to anybody, right? We need the consensus to have a particular input. People decide based on that input and give a output decision collectively, right? And that everybody accepts that output. So this is what we want a consensus mechanism to be. So putting all of these ideas together, let us define some technical requirements for consensus mechanisms. Okay, so now we put these, we've jotted down 4 technical requirements for a consensus mechanism. Any consensus protocol that adheres to these requirements are resilient to Byzantine failures. So we will talk about what Byzantine failures means, but let's first look at what these requirements are. First agreement, right? Everybody who participates should agree on the decision that is made. Final decision everyone should accept it, right? They can't say no, I don't agree, I'm not going to follow these rules at the end. If they participated, and if according to the rules of the consensus mechanism, if the decision is being taken, they have to agree to it. Second, termination. Every consensus mechanism should terminate. That is, ultimately some decision must be taken. It cannot be that after participating in the algorithm, there is no decision. Third is validity. Okay, if I'm participating honestly and I've been given an input, two honest people who've been given an input should get the same output if they followed the same steps.